Today, we are going to break down one of the most important ideas in all of modern AI. It's this hidden engine that powers so much of the tech you use every single day. We're talking about vector embeddings. So let's just get right into it. We ask AI to write an email, find a picture of a cat, or recommend a new show. But have you ever just stopped and wondered, how does a machine actually understand what professional email or funny show really means? I mean, it doesn't have memories or feelings, right? So what's the secret?
Well, the answer is actually pretty cool. It doesn't feel the meaning, it maps it. Just imagine that for every concept out there, the AI builds this huge, incredibly detailed map. A map where every single word, every sentence, even every image has its own specific location. It's quite literally a map of meaning.
Okay, so if we've got a map, every spot on that map needs coordinates, right? You need a way to pinpoint its exact location. And that is exactly how this whole thing works. We need a way to turn these abstract ideas into solid numbers that a computer can actually crunch. This is where you hear that term vector. Now, I know it sounds a little mouthy, but don't let it trip you up. A vector is just a list of numbers. That's it. Seriously, think of it just like a coordinate on a regular map. You know, a point might be 3, 8. That just means you go 3 steps over and 8 steps up. A vector is just the coordinate for an idea on our meaning map. And the process of creating that coordinate, that's called an embedding. So embedding is just the action of taking a concept, it could be the word queen, a picture of a dog, a whole paragraph, and translating it into its vector, its list of numbers. So an embedding is basically the street address of an idea on our map. All right, so we've got a map and we've got addresses. But what actually gives this map its structure? What makes it smart? Well, the answer is dimensions. This is what takes it from just a flat list of things and turns it into this rich, multi-layered space of meaning. Let's make this super simple. Imagine we're making a map just for animals, and we only have 3 dimensions to work with: size, friendliness, and habitat. So, for example, a mouse would be plotted as small, friendly, and land. An elephant, well, that would be large, friendly, and also land. And here's where it gets really clever. These coordinates, they automatically create relationships between things. On our map, a mouse and an elephant are plotted way far apart on the size dimension, but they're actually pretty close on the friendliness dimension. Their position on the map mathematically reflects how they are in the real world. And this perfectly shows the core idea of similarity. A dolphin and a fish, they'd be neighbors on our map because they're super close on that habitat axis, right? They both live in the water. But what about a dolphin and an eagle? They would be on completely opposite sides of the map, far apart in pretty much every single way. So on this map, being close means being similar. So our little animal map has 3 dimensions. But here's the absolutely wild part. Real AI models, like the latest ones from OpenAI, they don't use 3 dimensions. They use hundreds or even thousands. We're talking over 1,500 dimensions. And these dimensions, they aren't simple things like size or friendliness. No, they're incredibly abstract features of meaning that the model learns all on its own. It's kind of mind-blowing. So, we've built this amazing high-dimensional map of meaning, but how does an AI actually use it to find what you're looking for? Let's look at how it all comes together. You know, it's actually a really simple 4-step process. First, when you type in a query like pets that live in water, the AI turns your phrase into a brand new vector. Second, it plots that new vector right onto the map. Third, it just looks around for the other points, the other vectors that are closest to it. And finally, it returns those nearest neighbors as the results. Simple as that. But wait, how do you measure closeness in a space that has thousands of dimensions? I mean, you can't just use a ruler. Instead, it's all about direction. Using this idea called cosine similarity, the AI measures the angle between 2 vectors. The smaller that angle is, the more they're pointing in the same direction on the map, and the more similar their meaning is. Okay, so that's all the theory, but why is this such a big deal? Why is it so revolutionary? Well, it's because this map of meaning is the engine behind so many of the smart technologies that we completely take for granted now. Just think about it for a second. When your music app recommends a song that has a similar vibe, yeah, that's vector embeddings. When a search engine understands the meaning of your question, not just the keywords you typed, that's vector embeddings too. From those really advanced chatbots to systems that find similar products when you're shopping online, it's all powered by this one big idea. So, the most important point is this. If you remember one thing from all this, make it this one. Vector embeddings are what finally allowed machines to stop just seeing pixels and letters and to start working with the underlying meaning of things in a purely mathematical way. They translated our abstract world of ideas into the concrete world of math. And that leaves us with a really fascinating final thought. We've managed to build a mathematical map for the world of human ideas and concepts. So the big question is, if meaning itself can be charted and measured and navigated, what other complex, abstract worlds will AI learn how to map next?